So continuing with integration. So last time I said that integration was basically the opposite process of differentiation. And we have, just like we have for differentiation, we have a formula sheet that has a whole lot of integrations on it. So the formula sheet that you'll have seen looks like this, and we'll make sure we put a link onto that as well. And on that formula sheet, there's a couple of tables, and this one is labelled differentiation. It's quite a long word. And this one is labelled integration. So at this stage, we're looking at integration. So far you've used the differentiation table, and now we're going to have a go at using the integration table. So for example, I asked you to integrate 1 over x dx. What I would expect you to do is go and have a look on your integration table, and somewhere down here you'll see 1 over x, and over the side here it tells you it's log to the base e of x. And notice it's got a plus k. That's that constant that we were talking about last time. So I used c. Your formula sheet always appears to have a k on it. Either is fine. C, k, you can use any constant you want at all. So this just tells us that the integral of 1 over x, integration of 1 over x is log to the base e of x plus your constant of integration. Okay. And exactly like we did last time, you can read all sorts of exciting things off your table. So if we were doing, let's see what we've got, c goes to cx plus constant. This is if you're integrating the constant, you get that constant times x plus a constant. X to the power of n turns into x to the power of n plus 1 over n plus 1 plus a constant, and we'll pick one of the funny ones down the bottom. Let's go with tan x. If we integrate tan x, we get negative log to the base e of cos x. Okay, so there's some bits and pieces that we could do. So let's have a go at the integral of x cubed plus 10x plus 7. Okay, remembering what I said last time, that the integral sign and the dx are the things that say I'm integrating, so those sort of together, and the bit in the middle is what I'm actually trying to integrate. So this has got 3 bits to it, and hopefully we can find each of those 3 bits on the table. So x cubed is an x to the power of n, and this says, what do? I increase the power by 1 and divide by the new power. So if I increase the power by 1, x to the power of 4, and divide by the new power. That's all that one takes. Plus integral of tan x is negative. Oh, so let's make that a minus. Natural log e cos x. And 7 is a constant, so I'm going to integrate a constant. I'm going to get that constant times x. So 7x. And for all of these guys, they're all plus a constant. And you notice I haven't put 3 separate constants, because if you add 3 constants together, you just get a constant. So let's just put plus a constant on the end of that lot. And then we have got the integral. So this is now the integral of this thing. And notice the integration sign's gone away because I've actually done the process. This says integrate this rubbish, stuff, functions, maths, can't be rubbish. So it says to integrate these exciting functions, and this means I've done the integral. So I don't need the integration sign anymore. It's been done. I've done it. And I've ended up with this one over here. Let's have a go at one more on this video. So the integral of 4x to the power of 7 plus sine x minus e to the power of x dx. Okay, right, yeah, this should be fairly straightforward. Again, the integral sign and the dx are the bracket, and the thing we're trying to integrate has got, again, 3 pieces to it. So we should be able to integrate this. Okay, so the first thing is This 4 is just like when you differentiate. If you had a number out the front, you just left it and then dealt with it. So that 4 can stay out the front. So we're integrating x to the power of 7, which is the old power routine. So up the power by 1, divide by the new power. So x to the power of 8 divided by 8, and that cancels out, isn't it? It's x to the power of 8 over 2. That's getting a bit better. Plus the integral of sine x. Integral of sine, hang on, there's no sine x on my table. Is it on my sheet? On the integration sheet, there's no sine x. But, hang on the differentiation sheet, I've got minus sine x and cos x. Now, if what I'm telling you is true, and integration is just undoing differentiation, then if this is differentiation, that must be integration. So coming from here back to here is integration. So even though this is a differentiation table, if I go from that side to that side, it's integration. So if I want to integrate sine x, I'm going to get cos x, but the plus minus changes. So negative sine x turns into cos x, plus sine x will turn into minus cosine x. Yeah? So tricky thing here, it's not tricky, it's just you've got more information than you think you have. The differentiation table can work perfectly as an integration table when you're going that way. So anything on this side, you can integrate onto that side. Okay. And again, e to the power of x. Well, I haven't gotten e to the power of x in my integration table, but you remember when we differentiated, e to the x stayed e to the x. So if we integrate, it's still going to stay e to the x. So it's going to be minus e to the x. Plus c, plus c. And I guess I should fill out my line below it, seeing I started simplifying it. So that would be the integral of that, this function here. Okay, so you've got an integration table, and you've effectively got an integration table by anti-differentiation. So going this way is integration. On the, what has been sold to you as a differentiation table, when you bought it, you got a 2-for-1 bargain without even knowing it. Going back that way is integration, so you've got that built into it. Okay, so that's the basics of integration just using your formula sheet.